Hello and welcome to Introduction to Hadoop. In this video, let's learn about what is Hadoop and how Hadoop actually is become popular in the world of big data. This is my second video in the big data series, and if you're not watched the first video, you can just check the playlist in my YouTube channel. Today, we're going to learn what is the traditional approach problems, like what is the current problem in the world, and what is Hadoop, and why Hadoop existence is required, and evolution of Hadoop, and we'll learn a little bit more about HDFS architecture, and then some of the common Hadoop components. I'm not going to cover all of them, but some of the components we'll see in this video. And what are the popular vendors who are giving us Hadoop distribution in the market today? And finally, let's have a quick summary of what we learned today. Most of the time, we have problem with the data, like especially volumes, and we have no systems which can deal with a large amount of data within a single machine, because it's a matter of processing speed, or storage capacity and all that. That's one of the thing which we are expecting Hadoop to solve for us. And second thing is the variety. We always don't get data in one specific formats. We get images, we get videos, we get text files. It could be an XML, whatnot. So any different kind of data which coming in, we should be able to address them as well, along with the huge volumes. And finally, the processing speed. So today's digital era expect any answer within matter of milliseconds. Even I cannot even say seconds, right? How do we make sure that we process all this data and answer some of the consumer questions in the matter of seconds, or a matter of minutes, right? So in the initial days, when we started dealing with a lot of data, so there was a concept which came out called as a master slave architecture, where there is a master server which has a code base, and there is a slaves, a list of machines which usually also have a small piece of work. Let's assume in this case I have a server which has a code which can do, let's say, word count on a file, right? And I wanted to understand, for example, like I get data feed from Twitter, and how many times somebody has hashtagged big data, right? So when we start collecting such data, there is no simple way for us to do the approach, right? So let's assume I have this five set of machines within a cluster, which is actually start collecting this such data, and they hold them. And usually what happens is the consumer asks a question, hey, can you identify how many times big data has been used in a data we collected? The server machine will actually send a communication to all of its pair machines saying that, hey, can you send me the data, because I have a request to process, and all this these machines in the cluster which has collected data will start sending this data to the server machine. As soon as the server machine collects all this data, it apply the logic, which is the code which is there within the machine, and on this data, and start processing it. Start processing the request and respond back to the consumer. The problem with this approach is all these servers has to send the collected data into one server over the network, which is most costliest transaction, because we are trying to transfer terabytes of data over the network, which is slow and not the right approach. So what they thought about is, let's change this approach. So let's do this. So let data be there wherever it is, and let's send the code. Let's send the code to all the machines, and all the machines will actually run this code on the data which is residing in the same machine, in the same box. And once the calculations is done, the results are being sent to the server. Let's quickly look at what is Hadoop. From a definition perspective, Hadoop is a collection of open source software utilities that facilitate using a network of many computers to solve a problem involving massive amount of data and computation. So Hadoop is not one single software, it is a collection of software which actually help you to run some code on massive amount of data within a network. That's what Hadoop is all about. So how did Hadoop come in? So back in early 2000, the big data has actually started emerging, and a lot of people are having problems. That's when a team in Yahoo started exploring the option of how can we process such a huge amount of data, and that's how Hadoop was evolved as an open source project. The important component they built was called as HDFS, which is a distributed file system, and they also built something called as a MapReduce. MapReduce is basically a processing engine, and in the initial days, MapReduce also used to manage the cluster resources, which is basically it knows how to allocate data nodes, how to allocate memory, and all that, which was actually a Hadoop 1.0 version. And later, everybody started feeling that cluster management is not actually a MapReduce job. So they maintain the HDFS as is. They introduce a new layer called as Yarn. Yarn's responsibility is just to manage resources within the cluster, and which is basically an expansion to yet another resource negotiator. And on top of that, we have MapReduce, which is whatever we had. So in this case, it has been segregated to only do data processing, and there are a bunch of other tools for processing also came in. That's your 2.0. And Hadoop 1.0 was released in April 2006, and Hadoop 2.0 was available by May 2012. Almost 6 years, there was no other releases. Let's look at master-slave architecture in Hadoop. There is something called as a Hadoop node. So any machine within a Hadoop cluster is called as a node, Hadoop node. There are two kinds of nodes we call. One is actually a master node, and another one is a slave node. The master node responsibility is to talk to the consumers, or manage his jobs, or managing what needs to be done, and slave nodes, in the other hand, actually do the job. In the master node, we have two daemons running. One is actually called as a resource manager. This is takes care of all the resources and within the cluster. And the second daemon, which runs on the master node, is a name node. Name node actually maintains the metadata of all the cluster information, like how many data nodes I have, or where is the data, and how many replicas are there in the cluster, and all that is maintained within the name node. On the slave side, we do have another daemon running, which is called as a node manager, which actually manages resources within the node, as well as it also takes care of how is the actual job is getting completed, or how the job is going on. And the second daemon is called as data node, that itself is which holds the data, which gives some of the basic information about where's the data, how are they been distributed, and all that. So the resource manager and node manager work together, and that's when they manage the complete cluster resourcing, and that's what is actually called as Yarn. And similarly, the name node and data node works together to manage data, and which is actually called as HDFS. Quickly looking at HDFS architecture, it's very critical and crucial for us to understand HDFS, because Hadoop primary focus is that I should be able to store data distributed, and also should be able to process them within the distributed environment. So we just quickly discussed like what is name node. We already know it stores the metadata and number of replicas. Initially, there was only one name node. Then the newer version actually has name secondary name node, just to make sure that there's no pointer failure. These name nodes are actually runs like a master nodes, and then we have a data node as well. And there is a bunch of data nodes in a cluster, and they usually be getting segregated by racks. So in addition to that, we actually, to make a cluster more available as well as more reliable, usually data nodes have been distributed across the racks. So in this diagram, I depicted 7 data nodes, and they have been distributed across 3 racks. So each of these data nodes actually stores data in blocks. A data block is a 128 MB data storage. These data blocks are distributed across data nodes, and each data node has a bunch of data blocks, which will be a storage area for any data. So what name node does is it has a service called as a block ops, which actually knows that how data node is storing this data in blocks, and if anybody asks for such data in the future in the cluster, so they know where to go and get the data out. There is another important aspects we talked about is replication. So in the cluster, we don't replicate the whole file, we replicate blocks. So this is a small depiction of replication. If you want to visualize the actual replication, it looks like a cross wiring, like a lot of links here and there. So usually replication, what happens is that a set of blocks that get replicated into the other data node for more availability. So let's say I have a client running on trying to get some information, or let's say trying to write some data. And the client will say, hey, look, I have a 500 GB file. I want to write into the Hadoop HDFS. Can you help me out? So then what client is supposed to do is it actually asks the name node for metadata, saying that, hey, look, I'm trying to write this data into this specific location. There will be a HDFS location, which is a virtual location, and internally it mapped to specific data nodes. And what name node does is it's going to give the information that write to this specific location. And based on that information, it start writing data into the different data nodes and the blocks. Similarly, in case of read, client has to still talk to the name nodes to get metadata and then read data from the data nodes. Moving on, let's quickly look at different Hadoop components. So we just talked about HDFS, which is one of the underneath component of Hadoop. And on top of that, we have MapReduce, which is a distributed processing utility which runs on HDFS. Usually MapReduce is written in Java. Later they built some other utilities like Hive and Pig and Mahout. Hive is for those people who has no background of Java but are good at queries and dealing with SQLs. Hive is a query language platform where you can run the queries, which generally converts into MapReduce and runs on the HDFS. And scripting background folks like Uniscript, Shell script, and all those people also can write code in Pig, which is scripting utility, and internally converts into MapReduce. I'll not spend much time on the Mahout, which is basically now completely runs on Spark. Even Pig also latest version of Pig also runs on top of Spark. And in addition to that, Hadoop, we also have HBase, which is a NoSQL database, which stores data in a structured fashion. In addition to that, we should also need to have tools which can bring data into the Hadoop, which we have two of the familiar ones is the Scoop and the Flume. Scoop is a utility which can help you to pull data from any RDBMS like MySQL or SQL Server, We can pull data directly from RDBMS into the HDFS, or we can put back into the RDBMS. Scoop is going to help in that way. Flume, on the other hand, help you to ingest unstructured data from social media. And once we have so many number of tools, we should also need a workflow management, which is Oozie, which actually can help you to tie one or more utilities to run together to accomplish a job. So it's like any typical workflow. We also have a coordinator utility called Zookeeper, which coordinates with all the tools in the Hadoop. And finally, we have an Ambari, which is sitting on top of the complete Hadoop ecosystem, which is a web-based monitoring tool. You can, whatever we used to do for monitoring any of these jobs or workflows, or how is the data nodes are doing, how is the memory allocation, anything with respect to the Hadoop ecosystem, we can monitor through the web-based UI. That's actually called an Ambari. What are the popular Hadoop distributors in the market? There are 6 of them. One of them is Cloudera, Hortonworks, and we have Big Insight, we have Azure HD Insight, we have MapR, and we have EMR from Amazon. So all these vendors have the basic Apache Hadoop in the distribution, and they have written their own custom code on top of that to improve or help to do things better. We reached the end of the video, and let's answer a question called, why do we even need Hadoop? We learned so many things about Hadoop. Why do we need Hadoop? The primary thing is storage and processing speed, because now we're going to put data within the cluster or distribution. So it, of course, not just one machine as a power, like bunch of machines which together give us a computing power. Low cost, because it's not any specific server to take with just any commodity hardware. And thirdly, it's fault tolerance, because we just talked about, like, if one data node goes down, I have a replication of the data node, and they can help you to give you the data when one is not available. It's good at fault tolerance. And computing power, it's a horizontal scaling system where the computation power increases the more and more nodes get into the system. Finally, the flexibility, it's completely on open source, and if you want, you can directly use the open source Apache Hadoop to do this job, or you can use any of those vendors who has a custom code which is internally has Apache Hadoop on it. So that's all about Hadoop. In future videos, let's learn each of these components in detail. And you still have any questions, feel free to leave them in the comments below. I'll try to answer as soon as I can. And if you have any specific topics in mind which you need to know, do let me know. I'm happy to do a video about it. Thank you for watching. Have a nice day.